Recording, yeah. So yeah, my name is Max. Welcome to the second workshop of the semester. This workshop series is kind of like an introductory series, and since you kind of like Liz covered the most basic stuff previous week, and we're gonna basically add some stuff on top of it. We're just gonna focus mostly on physics and simple platformer mechanics. The thing is, it's not required for you to create a new project. So like if you have some ready, you can also work with that, or like you can just add a new project. It's really up to you. I just want to have a quick recap. By the way, like everything is looking clear, right? The text and stuff, like everything is clear. Maybe like I can just rescale the screen so that like it looks better. Just let me know if it's not working with you guys. So yeah, as you can see, maybe I should also have my mouse. Yeah. So this screen is, it might seem a little intimidating at the beginning, but like the chances are you're gonna use most likely like 20 or like 40% of what you're seeing in the screen. For example, like in this thing on the left, it's basically our hierarchy. We can just create game objects, or like let's say we just create an empty game object, and as you can see, whenever you click any of the game objects, you're gonna see its information on the right side, or like in the project tab at the bottom side of the screen, you can just basically see your folders and stuff. So like for example, if you open up your Explorer, you will see that there are a lot of stuff staying right next to the assets folder. The thing is, you don't really have to worry about like any of those stuff, at least for now. We will be mostly working on the assets folder. And yeah, I just want to create a pretty simple square. So for example, if you just right click and see like 2D object and go over to sprites, you can just create a square just like this. And as you can see, like we just created this empty game object, but like the only difference is that this one has a sprite renderer attached to it, while the other one has only like transform in it. And the thing is, like you see a lot of things when you right click, like audio, video, UI and stuff. The thing is, like all of them are just basically game objects with some components, some built-in components attached to them. So like if you just create a particle system, it's basically a game object, but like if you just remove that component, it has basically no difference than a empty game object. And yeah, that's kind of cool. Sorry. For example, like I can just use some of the slides of Liz. I think this whole graph is pretty important because like you just created project, and like you can just have like different scenes in just one project, and like in each scene you can have different game objects. Like they're usually like you only see 2 game objects, but like it's usually like tons of them, like hundreds and stuff. And for components as well. And yeah, I think this one is kind of like a key thing to remember when working with Unity. Anyway, so like we have this square. We can just, delete this empty game object that we have. Like with this square, we can just call it our player, as simple as that. And like, I assume you're familiar with how to create a script or like how scripts behave in Unity, they sort of act like another components that you can customize basically. So I'm just going over fast because it's basically some recap that I would like to do. If you right click to the assets folder, I'm just gonna create a new folder and call it scripts. So for example, if you keep your files from the previous workshop, I think most of them should be there. By the way, like you don't really have to create a scripts folder. It's just basically a good practice to have, so like you have your stuff more organized. Yeah, I just want to create a new C# script. If you just right click to the folder and go over create and create a C# script. As you can see, it just went over to the scripts folder directly. We can just name it a player. This one will be our basic player script. So it's gonna compile. Yeah, the thing is there are several ways to attach our player script to the player game object. You can just drag and drop it like this, or like if you feel like it, maybe you can find your player script inside the add component tab. We can just double click to open it up in VS Code. So yeah, this one is basically the built-in things that you're gonna see whenever you create a script on Unity. So the things at the top you see, those are basically C#'s data structures, or like some of the libraries, some of the built-in libraries that you can find useful. It contains things like queues, hash dictionaries and stuff. We are not going to use them in this workshop, so it's kind of like safe to delete it for now. So yeah, this start and update functions are basically built-in functions that Unity provides to us. So like if you have IntelliCode installed, you can kind of like differentiate built-in Unity functions with your own. For example, if you just create something like void jump, we're not going to use it just yet, but as you can see, it's kind of like labeled in yellow while the other ones are in blue. This one is basically a good way to differentiate them. So yeah, sorry. So that comment line at the top is pretty self-explanatory for the start function. So like the start function will be called within the first frame update. So it's kind of important, and I kind of assume that you guys all familiar with the concept of frames per second. You know, my game runs in 60 frames per second, FPS and stuff. And that's basically the same frame in the FPS with this one. So, and this update function is, the command is also pretty self-explanatory. It will be called once per frame. That means, for example, if your game runs 60 frames per second, this function will run 60 times per second. By the way, like you don't really have to know this. I don't think it's too essential to know that, but I feel like it's kind of like a fun fact to know, especially if you're familiar with frames per second and stuff. So yeah, I'm just gonna use a simple system where I can just move my character if I provide an input. So I'm just gonna have an if statement, and by the way, like since this function is called 60 times per second, you're gonna be like, I can assure you that that number is a lot. So this function will run a lot basically. If we just enter input dot get key down, and if we provide a key code enumerator that takes in the key D, so this function, so it's basically going to do, when you press the key, it will basically, and also like if you have IntelliCode installed, like when you hover over your code, you're gonna see some explanation. And like, it will basically, like when you press the key D, within the first frame that it detects that you're pressing the key D, this statement will turn true. Basically, that's what's gonna happen. So like, any questions so far? It's basically a recap. And by the way, like, we can basically access our other components. As you can see, like I mentioned to you that the player script that we have just created acts like a component. So that means within this script, we can actually access other components like sprite render or transform within that script. And that's quite useful. That's a quite useful thing to have. So with that, we can just use transform. And like when you press dot, you're gonna see that it will give you a lot of options like position or like local scale, local rotation and stuff. And you can be sure that the numbers that you're gonna get are going to be from this transform component. And yeah, we can basically make some manipulations with it. We can just assign a new value to it. And since like they're all vector trees, we're all gonna do, like everything is working with vector math, sort of. So yeah, instead of using like normal numbers and stuff, we're gonna have to use vectors. So for example, I just want to move to the right on the x-axis, right? So what I'm going to do is basically like provide a value here. And like the other values are basically the changes that I want to happen in the other axes as well. So for example, I'm gonna press D, I don't want any changes on the y-axis or z-axis at all. I just want to change the x-axis. And similar to that, we can just have something similar for the minus axis as well. I'm just gonna use key code A, transform.position. By the way, like you can just assign or like you can use the shortcut of plus equals so that like you don't really have to provide this. We can just have vector 3 minus 2f, 0f, 0f. So it's almost the same thing. Maybe like it's better if I just have it the same way. But like you can use your own preferred way if you want. Transform. All right. So this one is basically the most basic way to update the position of your player or update the position of a game object, sort of. So when we run this game, and by the way, like I assume you all remember the difference between the scene and game views. This one is basically what your player is going to see while I don't think they will have access to the scene view. So yeah, it's kind of like important. So as you can see, whenever I press any keys, um, it will basically move like 2 units, and like you can see the changes on the position when you make those changes and stuff. And yeah, and also we can do other stuff with it as well. And also it's kind of like quite interesting because the whole thing, like making a game, what we're basically doing is we're taking input, and like after taking that input, we're basically corresponding that input with an action. And that action is gonna make some changes on our game world, pretty much. Like it doesn't have to be a position, but for example, if you press the key space, I just want to make changes on my local scale. And as you may all remember, the scale is basically the values that you see like at the bottom of the transform. So what I want to do is, whenever I press the key space, I just want to update it by just with this vector. So we're not making any changes on the z-axis because our game is in just 2D. You don't really have to worry about the z-axis, at least when changing the scale. And also, just in case if you are not familiar with it, as you can see, like I'm adding this prefix f at the end. It's basically I just want to differentiate a normal number with a float. As you can see, vector 3 is taking in floats. I don't think you should get into like too much trouble if you don't, provide it with the postfix f. But it's a good practice. It's a good habit to have. Like if you're using floats, just have a 1f at the end. So yeah, like if you press the key space, you're gonna see that the scale of your character will increase, or like you can also have something pretty similar to that. I'm just, make it more faster. So yeah, you can basically play around with it. There are like tons of different stuff that you can do with just transforms and stuff. So yeah, and also one other thing, you can basically have some variables in your script, so that like you can make those changes from your editor, so that like it gets easier for you to debug some stuff. So for example, this one is kind of like a bad code. So like if you make it a variable instead of like 2f, we can just have a public variable, public float. I'm just gonna call it speed and assign it to 1.5f. So if I have this value in here, and if I just provide this keyword public to it, that means other scripts, other components can access to it as well. And if you keep it public, that means you're gonna see that on your editor as well. Hopefully. Oh yeah, I have to save it first. And like after you save, it kind of like compiles and stuff, and it takes a lot. As you can see, like there are some changes and stuff. But like, however we change this value, nothing's gonna change because like we haven't assigned it to anywhere. So we can just assign this speed value to both of those sections in our code. So like, for example, we're basically saying that whenever I press the key D, I want to move speed units to the right, or like I want to move speed units to the left if I do that. By the way, I'm just gonna delete the scale part I just did. You can definitely play around with it. So yeah, compiling. So if we play our game, and if we press the keys D and A, you're gonna see that the change will only happen like 1.5 units. And if you can also like make those changes and like change it to something like 5. And as you can see, the change gets quite bigger now, sort of. And like I just kept it in 5. If I just stop the game, it will return back to its normal value. That's kind of like a good thing Unity provides to you because it's kind of like good for debugging. Sometimes you just want to make changes while you're playing the game and you don't really care about any of them. And like that kind of means it's pretty discardable and you don't really have to worry about some of the stuff, some of the changes that you do on your game while you're just playing it on the editor. And yeah, that's basically sort of the recap that I had in mind. For example, like our player has a color field, our player's sprite render component has a color attached to it. So like with those values, you can just, create any colors that you have in mind. I think it's quite interesting. It's not really related to our topic today, but like whatever, like you kind of need just 3 of those values to, create any of the colors. You can definitely play around with it. And yeah, I'm just gonna return it back to white. So like at this point, do you have any questions? That was basically the recap. And that was kind of like the summary of what you have seen in the first workshop. All right. So first of all, I would like to start with just, like I assume everyone has a player object now. I think we're gonna work on that. So yeah, I just want to, like, since the whole point of this second workshop is physics and platformers, I just want to create a simple platformer sort of game that we can, test and play around with. I'm just gonna create a 2D object, sprites, and square. We're gonna do this a lot because like I think playing around with squares and stuff, like I think they're pretty simple and it teaches you a lot of things. That's just, and by the way, like these are basically the tools that you can work with. So for example, move tool, rotation tool and stuff. I usually use the fifth one, because like it kind of lets you to move your objects and also stretch them as well. I think it's quite useful. It's basically my favorite one. You can use any of them, or like maybe, for example, if you feel more comfortable with scaling your objects within here, you can also do that as well. Um, yeah, like this. I mean, whichever way you're comfortable. I don't think there's a best way to, use the editor. It's basically your own preferences. I'm just gonna use a different color to sort of differentiate our ground with our player and stuff. I'm just gonna use green for this one. And let's make our player red. So like, do you have any questions so far? We just stretched this ground, like we have this player which happens to be red. So yeah, and by the way, if you want, you can also add a background for your game. And for example, like if you want, it's kind of like an optional thing. So for example, you can just create an 2D object, a square again, and like you can just stretch it all the way like this. And you're gonna see that it's kind of like blocking each of your objects and stuff. So we can actually fix that. As you can see, like in the sprite render tab, you can see the sorting layer. So for example, everything is in the default sorting layer. Your player, your ground, and stuff. In order to have the background on the back of the sorting layer, we can just add a new sorting layer and just call it, I don't know, like background layer. And be sure to drag this layer to the top so that like it's actually on the background. Like this. And also don't forget to like get to this background object and change the sorting layer to the background layer that we have just created. As you can see, it's basically staying on the ground, and whatever we create, since like whatever you create, it will be on, I'm just gonna use a different color that looks better to your eyes. I don't know, maybe this one. So if you create a new game object with, I don't know, like any sprite renderer and stuff, for example, like a capsule this time, you're gonna see that the default sprite renderer setting has the sorting layer default attached to the default game objects that you create. And it kind of like looks ugly. By the way, like let's just, like if you have the background, let's just rename it to something like a background so that like it's more distinct than the other objects. So yeah, any questions so far? We just created a big square and just change its color, change its sorting layer, and so on. And the good thing is you can just, instead of having the default square that Unity provides us, we can just use our own sprites if we want. So for example, I'm just gonna create a new folder on the assets. I'm just gonna right click, create a new folder, and just basically I'm just gonna call it sprites. So yeah, I already have, I guess not. Oh yeah, I have this dedicated folder in my desktop. You can just open up your browser and like look for a cool background that looks good to your eyes. You can just drag and drop it inside your editor just like this. It's pretty simple. As you can see, our background sprite, our background.png, is within this sprites folder. And the final thing to do is to just drag, so like we have this sprite open. And like, let's just open up the background and like drag and drop our sprite into the sprite render of our background object. Just like this. And also, oh, I think that this one's quite important. Just don't forget to change the color to white after you change the sprite, because it will basically work as a, yeah, like I stretched my background object a bit too much. So yeah, you can definitely work around with it. You can just, you know, rescale your scene and stuff. Like play around with it. So yeah, that's basically it. And if you feel like it, maybe like have a little filter to it so that like it looks more customizable and stuff. And yeah. Any questions so far? This one was basically a small thing that you can do. So yeah.
Do you want to walk around and check your activity?
Oh yeah.
Just give them some time.
I guess we have a
Yeah. Can you show again how did you make the square one in the background?
square one on the background. Yeah. A square one and the background, right?
Yeah.
So yeah, you can just right click and open up a 2D object like this, like sprites.
Yeah. You make a square.
And yeah, after that, you can rescale, or like you can also keep it if you want. And what you're gonna do is then, if you like, for example, stretch it like this, it will just cover the whole screen. So what you're gonna do is you're gonna add a new sorting layer to your game by clicking this plus sign. And like after having this new layer, what you want to do is you're gonna drag it to the top so that like it's at the top of your layer hierarchy. And yeah, like after that, when you stretch it, you're gonna see that it will stay on the background. Like this one doesn't have any anything, like it's not attached to a layer, so it's not showing it like this. But I'm just gonna delete it, like maybe like have it over here. But in the background, as you can see, it has this background layer attached to it. So like if you feel comfortable with it, you can just have a new sprite imported to your game like this, and you can also just drag it to your sprite render.
Thank you.
You're welcome. So any more questions? You're all good. All right. So let's get to some basic physics then. So yeah, physics. So one of the best parts of Unity is that it's like providing you with all of those cool stuff, like the physics, the colliders and stuff. The thing is, you don't really have to use the physics system, physics simulator that Unity provides to you. You can actually have your own like whole system implemented in Unity engine, but it's pretty complicated. And I'm kind of like saying this to you because you kind of have everything you need to create a physics simulator, because like we have objects, right? We have the world and we have the coordinates. So we have all this position, rotation, and scale. So if you want, like in theory, like since you have the position, scale, like everything, you can actually simulate physics by yourself if you want. But it's pretty complicated, and Unity already provides a system to you. So like for today, we're gonna use Unity system for that. So, and by the way, we have the background, we have the player, we have the square. I just want you to rename this square with just ground. And it will be basically the ground for our platformer game. So yeah, perfect. After that, if you click to your player, I want you to add a new component to it that is called Box Collider 2D. So, like as you can see, like there are usually two alternatives for each shape. We are definitely going to use Box Collider 2D because Box Collider, like default Box Collider, actually works with the 3D version of Unity, and since like we are just working with 2D, it's basically more optimized for the 2D, and I don't think it might have some problems with 2D as well. For example, it might not detect some of your functions and stuff, so it might cause some problems. So we just created this new Box Collider. Any questions so far? All right. So if you open this Box Collider, you're gonna see a lot of things. The thing is, we are not gonna use like all of them, definitely not all of them, but like after you click some of those stuff, you're gonna see a lot of things, like layer overrides. We're definitely not gonna go over them today. Or like you can see some info and stuff. You can see the detected contacts of this collider. And by the way, this collider is basically a system that detects collisions on your game. So for now, just this player has a collider attached to it. So we can also add a new collider to this ground as well. So let's just do that. You can just click to this Add Component tab, search for Box Colliders, and just add a 2D Box Collider to our ground object. So yeah, I don't want to give too many details just yet, because I kind of want you to see it in the action. So we just added these Box Colliders to our game object. So now, when we run our game, obviously nothing's gonna happen, because while these Box Colliders will try to detect one another, but still our player or the ground doesn't react to the Unity's physics simulator just yet. So what you want to do is just be sure that your game is not played when you're making those changes, because those changes will not be saved when the game is running. So yeah. Oh, what have I done? Anyway, just click your player object and like add a new component, and it will be called Rigid Body 2D. As you can see, it's just like colliders. You're gonna see two alternatives to it. Definitely pick the 2D one. I did that mistake before. I'm not telling you this because to, in a like looking down manner or something. I actually did that mistake a couple of months ago, and it's definitely not pleasant to try to debug it, because like the compiler and stuff like doesn't tell you what to do in those situations. So we have this box attached to it. And as you can see, like we're not gonna get into this rigid body yet. Or like maybe we can just start running this game. And if a box collider 2D and a rigid body is attached to your player, along with a rigid body 2D attached to your ground object, you're gonna see that your player is actually reacting to the physics system, sort of. As you can see, it's kind of like gets affected by the gravity, because Unity sort of provides you with this whole gravity and stuff. And as you can see, whenever it collides with this ground, it's just gonna bump into one another. And that's basically, like, there are tons of stuff happening on the background. And yeah, you can definitely play around with it. For example, like if you mold the ground object like this, it's basically physics, sort of. So yeah, let's get into the details. So we have those box colliders, right? Box colliders are basically, and by the way, like, any questions so far? I'm just gonna explain all of the stuff. Box colliders are basically the range of your game object that is independent from the shape of it. For example, I'm just gonna play the game and make some changes with the player object's box collider. Like, do you see those values, offset and size? Box collider is basically a shape. So for example, if you increase the size of it, if you increase the size of the box collider, you're gonna see that the sort of reaction range of it changes as well. So for example, if you get into the scene tab, maybe like I should change my background color to something else to visualize it better. So like, for example, when I pick my player object, you're gonna see this little green range, and that is basically our player's box collider. So like, if you make changes to it, like change the size on the x-axis, you can also change the offset like this. You're gonna see that it will react differently and stuff. It's pretty cool. And one thing to consider is that, like, it's definitely independent from the renderer itself. So yeah. And by the way, you can also play around with the ground's range as well. Like on the x-axis, on the y-axis, you're gonna see that it's reacting differently and stuff. Just be sure to play around with it to get more comfortable with it. And like, if you're done with it, just return the offset to 0 and size to 1. And also, one other thing I want to mention is that the size that you play around with is actually local size of your game object. For example, if you rescale your player like this, you're gonna see that the size and offset and everything will remain the same. Because what's happening, and by the way, like, you can see the range. You can see the range that it's kind of like reacting whenever you change the scale. The reason for that is this whole size, this whole offset is local to your game object. So for example, when like Unity is making some calculations on the background, and like if you change the scale, it will first look at the global scale of your game object and like add those values basically when calculating your box collider's bounds and range and stuff. And yeah, that's basically the colliders. And one other thing, we also added this rigid body. As you can see, it has the gravity scale, linear drag, mass, and stuff like lots of physics going on here. And like in order for your player to react to the physics, this one should remain open, basically. If you don't have a rigid body, it won't react to any physics. Just like this, yeah. So, any questions so far? We basically added those colliders to the player and to the ground. Collider is basically the bounds and stuff, and rigid body sort of activates the Unity's physics on the game object that is attached to, right? And yeah. Yeah, you can definitely have some fun with it to, get more comfortable with it. You can just, I don't know, change the rotation of the ground, like this, on the scene screen, like this, yeah. And like one other thing, just like the background, a small optional thing that I would like to show you guys is the physics material. Let's just create a 2D object. This time let's make it a circle. I'm just gonna keep it open like this. Right click, 2D object, sprites, circle. And let's just attach a circle collider to it. This time, since we are working with circles, we're just gonna use the circle collider. The only difference you're gonna see is that it's gonna take in a radius and an offset instead of a two-dimensional vector. Yeah. You can also like play around with the range and stuff of the collider. And also don't forget the rigid body. We want this circle to react to the physics of our game. Like this. We don't really have to make any changes on our rigid body 2D. And now, one thing I want to add is that I just want you guys to create a new folder in here, and let's just call it physics materials. The thing is, we're only going to have one physics material, but yeah, you can also like have your old stuff laying around. It shouldn't really matter. It's basically a good practice, a good habit to have. I'm just gonna go to right click, create 2D and physics material 2D. I'm just gonna keep it open right here. Create 2D physics material 2D. And now it will create a default physics material. I'm just gonna rename it to bouncy. We're basically going to take this, we're gonna take this and attach it to one of the colliders, and those are basically like, you can think of this whole physics material as a module. It will basically add this friction and bounciness values to our collider, so that like it's more advanced in a way. I'm just gonna assign friction to 0 and bounciness to 1. And also just get into the game, open up the circle, and like just basically drag and drop our bouncy physics material to the circle collider. gonna see that this circle object is gonna continue, like, start bouncing. You can definitely play around with the bounciness value. For example, since the bounciness is 1, that means wherever you start bouncing, it will basically return back to it. But for example, if you just change it to 0.75, then, and by the way, like, you also have to restart your game because like the changes are not happening in our scene, but rather happening in our, file system, sort of. So you have to, like, after making your changes, you're gonna have to restart your game. And as you can see, it slowly gets to the ground and stuff. And like, aside of that, maybe like you can just change it to 2. So that means it will double its distance to the ground whenever it, bounces to the ground. You're gonna see that it goes a lot longer now. So, any questions so far? This one was basically one thing that I wanted to mention. We're not gonna work with bouncing objects for this workshop, but yeah, it's a cool thing to have. For example, like maybe you can have a game where you have, I don't know, something like a table, and the player could just try to, hold the ball in line and stuff. Yeah, there are like a lot of tons of stuff that you can have with physics. Oh yeah.
So how did you assign the bouncy to the circle again?
Oh yeah. All right. So I assume you have the physics material and like everything is set up, right?
Yeah.
So just click to the circle game object and just basically drag and drop to the material segment on the circle collider. You can also click to the, I don't know, like dot symbol on the right. It will basically show up in here as well.
It's not showing up for me, I'm not sure why. It's not showing up for me, I'm not sure why. When I try and drag it, it doesn't want to put it in.
Is it physics 2D or? Oh, yeah, I guess you have to create a 2D material. 2D, like this. Yeah.
Oh, okay.
Yeah, that's fine. So like you can make changes with it like this. You can set the bounciness and stuff, and it should work. Any other questions? I'm just gonna have a little break, and then we're gonna get into the coding segment of this workshop, and let us know if you have any questions. Resume the recording. Anyway, so yeah. First of all, I'm just gonna delete this circle game object. You can keep it there. Definitely, you can just keep it. I'm just gonna delete it just to make things a bit more organized. Anyway, so first of all, I would like to start with the tags. So tag is basically it's a pretty useful tool, and the thing is there's no best way to use tags. They can be whatever you want actually. For example, I just want to, this one is sort of like a way to label your game objects so that like whenever you access them within the script, it's kind of like a good way to differentiate them. So, for example, I just want you to open up the ground game object and like select the tag and select add tag option for it. I'm just gonna add a new tag and basically call it a ground. It will basically make more sense after a while. And for example, we can just tag our player like this. And also, as you can see, we just added this ground. That means it's kind of like a part of our game now. So like, for example, you can, if you have other grounds and stuff, you can just add this tag as well. For example, let's just tag our player with the already provided tag, player, like this. So yeah. I'm just gonna give you another built-in and useful Unity functionality that sort of lets you to detect collisions on runtime. And like, I think it will make more sense after we create all of those stuff. So like, I just want you to open up the scripts tab, right click, and create a C# script. I just want you to call it ground. We're just gonna have this simple ground game object. It's gonna compile. It shouldn't take a while. And just like we do, we can just drag and drop it to our ground game object. So now our game object should have, a ground game object should have this. And by the way, don't forget to attach the ground tag to it. Like, any questions so far? We just added a new ground, added a new tag. Basically tag our game object with ground. And also we just created and attached this component right here. It's gonna be a pretty simple game object. So yeah, if you double click it, it will be open in Visual Studio. Just like I mentioned, we're not gonna use the two using statements at the top. And the thing is, we're not gonna use the void start and void update as well. So, and by the way, like, I just want you to see that each script, like, they all can have an update and a start function, and like they will most likely run in parallel, sort of. It's more like a bit advanced topic, but like the thing is, multiple scripts can have their own updates and like start functions. Anyway, so I'm just gonna create this function called void on collision enter 2D. So like when you type in on collision, you're gonna see a lot of different functions in the autocorrect. Let's just use the one with the on collision enter 2D one. And the working, and as you can see, the color sort of changed. That means it's a built-in function that Unity provides to you. So yeah, what's gonna happen? First of all, it works quite similarly to our getKeyDown function, sort of. And also, like, for example, we could have, you don't have to type in those stuff, but like input getKey. For example, getKey will return true when the key is being held down. Or like, for example, you can have getKey up, and that will return true only if the key is stopped being held, basically. And these whole on collision enter, on collision exit, on collision stay, they're pretty self-explanatory. But we're gonna use on collision enter 2D. Sorry. So I think this function is pretty useful because like it's giving us a chance to get more information when a collision happens. And since this ground script is attached to our ground game object. So yeah, it will be pretty useful. And this function will take in a collision. And this collision, on collision entered to the function, will be called whenever a collision happens. For example, like if you have IntelliCode installed for Visual Studio, if you press Control or I guess Command in Mac, like if you Control left click, you're gonna see the functions of or like attributes of collision 2D. So this one will basically provide you with the information of the collision that just happened. So you can have informations of, I don't know, yeah, like informations about the other objects, rigid body, other objects, collider, their velocity and stuff, like lots of things. But instead, what we're gonna do now is we're just gonna print something just to show that it works. So let's just type in debug.log and let's just type in there is a collision between that will be the game object name. As you may all remember, this ground script slash component is attached to a ground game object, right? So like we can actually access the game object attributes, or like we could also access to its like transform.position and everything. It's basically something like a virus. So like you can just, you know, find the information of the game object because like it's attached to it. It has access to all of those stuff. So there's a collision between game object.name and so this part might be a little tricky. So we have this collision object, right? We can access the other game object that we have collided with directly, because this collision 2D object kind of lets us do that. So we're just gonna get the collision.game object. This one will be the other game object that we have collided with, and basically get the name of it. So that's basically all of the stuff that we want to do. Don't forget to save this file, and as you may all remember, this ground game object has a collider attached to it, and also our player has a rigid body and a box collider attached to it. That means it will react to the physics of our game. And when we run this game, if you open up the console, you're gonna see that you're gonna see the prompt. So like you're gonna see that there's a collision between ground and player. For example, I wish I didn't, you know, deleted the whole circle thing, but like I can just have it. You don't have to do the stuff I'm doing right now. Or like you can also use the editor itself directly, just to showcase the print statements that happen. So like as you can see, there's a collision between ground and circle, and like you can also have it and like drop it like this. This function will be running only at the time, only at the frame where there is a collision happening. So like any question? So yeah, I think this function is pretty useful. Like maybe now we can just get into moving our player using the rigid body itself. So yeah, that was basically all of the stuff that we wanted to do with the ground.cs, that ground file that we have just created. So yeah, let's just open up our player script now. We're gonna use a better way to move our game object. So I'm just gonna use a private rigid body 2D, and I'm just gonna call it RB. What I'm trying to do is, this player object has a rigid body attached to it, right? So this rigid body has its own attributes. It has this gravity scale, it has this velocity, it has this, like everything. What I want to do is I want to access this rigid body and like change the velocity values by myself. So we have this rigid body object, but for now, this rigid body object is empty. We can just use this. I assume you kind of know this function. I'm going to explain it anyways. Rigid body 2D. So get component. It's one of the most useful functions that you can use in Unity. The whole purpose of it is basically like, give me the closest component that has this value to it. You can actually use the sprite renderer version as well. However, it will give you errors because you're trying to assign it to a rigid body 2D object. So yeah, that's basically one way to get a component from a game object. You're gonna see that there are a lot of different alternatives to it as well. For example, get component in children, get component in parent and stuff. But what we're looking for is the rigid body that is inside our game object. So yeah, for example, if you want to play around with the RB object itself, you're gonna see that it has a lot of different values, get type, get vec, gravity scale, maybe like velocity. That's definitely the value that we're gonna play around with. So yeah. Any questions so far? We just got the component from the game object and assigned it to a variable. So this one is basically the ugliest way that you can update a position of a game object. But it kind of works and it's pretty simple. But one other way that you can do is this. Whenever I press the key D, I'm gonna update the velocity of our rigid body to a new vector, and that's going to be a vector too, because as you can see, our rigid body is rigid body 2D. So like any velocity, any value corresponding to it is going to be in vector 2 because we are in a two-dimensional world. So I'm just going to assign the value speed to it. And like I'm just going to use rb.velocity .y to the y-axis. The reason why, the thing is, you kind of have to have this sort of notation because Unity doesn't really let you update values, update axes directly. Like I wish I could do something like this, but Unity doesn't allow you to do that. So basically what's happening here, whenever I press the key D, I want to change the velocity on to speed. on the x plus x axis. And I don't want to make any changes to my velocity whatsoever, because this velocity might be pointing, like this velocity shouldn't have to be 0, because like in Unity Simulator, for example, if our game object is at the top, its velocity should have a different value as well. So for example, and also we can just have the same values, sort of the same values for the other way as well. The only difference is that we're gonna have the speed on the x-axis to minus, because we want to go to the other direction, right? And also it would be better if you use else if in here. So for example, if the B key is pressed, go right. Else if the A key is pressed, go left. And that's kind of like important. Else, if none of those keys are pressed, then we're gonna assign our velocity on x-axis to 0, and the value on the y-axis should remain the same. Yeah, any questions so far? We can basically play our game, like play around with it. It will take a while. Yeah. Yeah, one thing is that since we kept things to the get key down, right? So it will try to change the speed only at the first frame that there is when this key is pressed, right? So instead of using get key down, let's just use get key like this. And like maybe just to be sure, we can just change the speed a bit more so that like the changes are a bit more visual. Yeah, maybe a bit more. Like for example, on the editor, you can just change it to 5 directly. As you can see, like it will react a bit more and stuff. And yeah. So that's basically a better way to move your game objects by using the velocity and stuff. And like you can see that the velocity changes as well. For example, like I just click the player game object and get inside. I just got inside the rigid body component. We can just check the information that is provided to us, and it seems there is some velocity that is happening towards the y-axis. Or like, for example, if you just happen to have it like on the ground, you're gonna see that the velocity will increase, sort of. And yeah, that's basically a better way to move your objects. So, one other thing, so since we're making this platformer game, let's also add a jumping mechanic to it. It's a little bit more tricky, but not entirely. So we have all of those like everything is happening. It's just handling the changes on the x-axis. Just to visualize stuff, you can just have it right here as well. Y-axis. So we're just gonna have a new input handler, input checker that will look for the space key. Get key down. I'm just going to use get key down instead of get key because I only care about the exact time where I press the space key. Any questions so far? I'm just going to implement a jumping mechanic. So yeah, just to keep things a bit more organized, I'm just going to have a jump function right here, and I'm just going to add this function inside this statement, inside this block. So if we get the RB, the rigid body component, and change its velocity, as you may all guess, we're not going to do any changes on the x-axis, so we can just have the x velocity over there. We're not going to make any changes to that. However, we're going to increase our velocity on the y-axis whenever we press the key space. So let's just have a value like 5f. And also, just to be better programmers, we can just have a variable for it that has the name jump force. And it can be assigned to, I don't know, 5f, like this. And if we play our game, hopefully whenever you press the key space, your character should jump. Yeah, like this. Like maybe increase the speed a bit more to something like 4 or something. And yeah, like this. Oh, and also as you can see, whenever I collided with the circle, the rotation of our player kind of shifted like this. Like if you wanted, you can just keep it, but there's a way to actually play around with it. I'm just gonna copy and create a new ground object just for visualization. And by the way, if you copy and paste, it will keep the exact attributes in the box collider. It should also keep the ground and stuff, everything should be there. So as you can see, the character sort of rotates. But if you get into the box collider, no, not here, rigid body it should be. Yeah, if you get into the rigid bodies of the player and freeze the rotation Z, that means the Z rotation of your player should be fixed from now on. So it won't rotate just like it did previously. That's basically one thing you can add to your game. So yeah. One other thing I would like to add to the game is that usually whenever you play a platformer, the number of times you can jump in a game is sort of limited. So you kind of want to limit that, but I don't think I have too much time, so I will instead maybe at the end I will try to quickly show it to you guys, but I just want to add a win condition to our game. So yeah, what I want to do now is to create a simple square object. This one will be our winning state, basically. I'm just gonna have this square, and like make it a bit bigger. And I'm just change its color to something like green, and like change the alpha a little bit so that like it seems like a part of the game, but also it's not. You can definitely play around with that. And yeah, so I'm just gonna call this goal area to this game object. Any questions so far? I just created a whole new square and renamed it to a goal area, and I also changed its color, basically.
It's already 9, so you should, if you want to
Yeah.
do something small, you should just finish it up.
Yeah. So yeah, that's basically the goal area. So whenever we get into this area, we just want to prompt our player that they won the game, sort of. So if we play our game and like move our player inside here, nothing's gonna happen because there's no collider attached to it. So let's just attach a box collider to our game, to our goal area. And I also want to add this tag to our goal area as well, just to be more organized, and I think it will make a bit more sense afterwards. Let's just add a new tag. The screen, you basically click this tag screen, click add tag, and let's just call it goal area. And let's just attach this goal area to it. And like if we run our game like this, so as you can see, it doesn't let our player to get into this goal area. So what we're gonna do is we're gonna check in this box. So this box is triggered. And by the way, like I just want you to know that I'm inside this goal area game object inspector, right? For example, if you check in this is trigger box, then we can sort of enter inside this box collider 2D. It won't bump into each other, but still, we still want to understand if the player enters this area, right? And by the way, I'm just going to disable this circle. So yeah, like if you open up the player script, I just want you to remember, so this function was built in on collision enter 2D. So there's an alternative to that, which is called private void on trigger enter. You're gonna see that it's pretty similar to on collision enter. Instead, it's just on trigger enter. It's basically an alternative to it, because the thing is, the trigger colliders are basically a different sort of colliders. So they can see the collisions, they can detect the collisions, but they cannot be affected by the physics simulation. That's the only difference. So like, for example, if you want to go over objects, but still want to detect that they're colliding in a way, you're gonna have to use triggers. Let's just, for the goal area, let's just enable is trigger. And so yeah. And just like on collision enter, this one will work quite similarly. Whenever there is a collision, a trigger enters, we can just, a trigger and or like you just collided with a trigger collider. So yeah, after it compiles, we can just get into this area, and I don't know why, but it's just collided. Have the goal area. It is a trigger. I'm not entirely sure, but it doesn't seem to be reacting. But what I was trying to do is maybe like should I use onTrigger enter 2D if so basically what I was trying to do is I was just gonna use the tags of the onTrigger enter 2D. So basically this goal area has a oh no, maybe it's I'm just gonna try it one more time, and like if it's not working, I can just quickly show it to you guys at the beginning of the other. Oh yeah, I guess the problem was just that I didn't save the code. So like if you just see, if I just this trigger is checked in, so like this one is a trigger collider. It's a special kind of collider. If I just go in, you're gonna see that this label is over there. But the thing is, we wanted to react differently for different kinds of trigger colliders, right? For example, maybe the other object that we have just collided with might be a game object that has the tag goal area. If that's the case, we want to do something different. U1, and maybe destroy the game object afterwards. For example, like maybe we can have another trigger object that happens to be a circle. Let's just call it a coin, for example. And I'm just gonna add this tag coin. I'm just gonna do it in a fast manner because it's repetitive sort of. I'm just gonna not a box collider, but rather circle collider. And I'm just gonna make it a trigger. I'm just gonna change its color to yellow so that like it looks more like a coin, right? And I also want to, so yeah, if we collide with a trigger that happens to have a tag that is called goal area, we're gonna react like this. But if we happen to collide with a game object that has the tag coin and they happen to be a trigger, then we're gonna destroy the game object, collision that game object and print out debug.log. You just picked a coin like this. When we play our game, you're gonna see that it will react differently for different collisions. Is it not trigger? Didn't I save it? Oh, they're not tagged. I see. And by the way, like you can just pick everything up by holding the shift key and click the tag, add the coin tag to all of them, and hopefully it will work now. So yeah, if you go into the coins, you're gonna see that it will prompt you that you picked up a coin, and if you get into the goal area, your character just dies, and you have this script, you have this text that says you won, basically. And that was basically the whole presentation I have for you guys. These are basically some of the useful links that you can use. And like if you have any feedbacks, or like if you're not in our Discord, you can definitely join up. For the next workshop, I'm planning to do something like a bullet hell game. So like if you happen to be interested with it, I'm just gonna talk about game managers. I'm just gonna talk about particle bullets that you can shoot or you can dodge. I'm basically working on that still. But like if you're interested in that, definitely join. And if you feel like it, just please leave a feedback.
Next week's workshop is in a different room. It's in 112, which is nicer.
Oh, yeah.
And I believe the workshops for the rest of the semester